Hey everyone, welcome back to my Calculus 1 series. In today's lesson, we're going to be talking about logarithmic differentiation and derivatives of logarithmic functions. One of the few functions that we haven't covered so far in the differentiation series is the logarithm, so log b x. We still don't know how to take the derivative of this function, but we will be going over that in this lesson, and it's actually fairly simple. If we're asked to find the derivative of this function right here, the derivative of a logarithm just basically follows a formula. So the formula goes like this: 1 over x and then ln b. So what we're going to do is we're going to take this x value, and we're essentially going to take the reciprocal of it, 1 over x, and then we're going to multiply by the reciprocal of 1 over the ln of the base. And that's why these two kind of get combined like that. Here is a quick little example, and if we're given this function where f of x is equal to ln of x cubed plus 1, we can quickly see that, again, this is a composition of two functions, so we are going to be using chain rule, but we could see that the first function, like the top level or first function we want to call it, is the ln function. So if we think about how we're going to go about this, we're going to follow this formula right here. And the formula says that all we do is we take 1 over x, where x is the input to this function, the ln function, and then we're going to take the ln of the base. And in this case, the base, if you remember, the ln, this is just like a log with base e. So if we just want to add our x's here, but this is essentially the same thing. The ln, it's just a logarithm with a base e. So let's follow this formula. Let's take 1 over x. In this case, x is the input to the ln function, which is x cubed plus 1. And we're going to multiply by the ln of the base, which is just e. But again, because this is a composition of two functions, we're going to need to use chain rule. And now, since we found the derivative of this function, the outer function, now we need to find the derivative of the inner function, which is x cubed plus 1. And again, that's not too difficult. We should know how to do that by now. It's just going to be 3x squared. And we can go on to simplify this by saying it's 3x squared over x cubed plus 1. And this ln e is going to equal to 1. So we're just left with this function. And essentially, this is the derivative of this weird looking logarithm, or it's a ln function. But yeah, nothing too difficult. All we have to do is just follow this formula where it's 1 over the input divided by the ln of the base. Now we get into a topic that's very applicable to difficult functions, and if we're trying to find their derivative but there's like a lot going on in the function, we can use something called logarithmic differentiation, and it will help us immensely. Essentially what we're going to do is we're going to leverage the logarithm laws. So we want to use this in scenarios where we have very complex functions that have like a lot of powers. And powers, I mean, as in like x squared, or like x to the half, or like x cubed. So a good example would be if we have this function f of x is equal to x to the power of 3 over 4 times the square root of x squared plus 1 over 3x plus 2 to the power of 5. Now, of course, we could use, let's say we were asked to find dy over dx, meaning the derivative of this function. Obviously, we could use quotient rule and then product rule and then multiple chain rules, but that would be a lot of work. Instead, what we can do is we notice we have lots of powers. We have this 3 over 4, the square root is actually a power of a half, and then this 5 right here is another power. So we can use logarithmic differentiation. And what we do with logarithmic differentiation is we essentially started off by saying that y is equal to this function right here. Now, what we're going to do is we want to basically leverage the ln and logarithm laws to simplify this stuff. Because ln and logarithms have this rule where if you do, let's say, the base of an exponent, or sorry, an x to the power of 3, this is like saying 3 times log bx. So we could see that we've simplified this a lot by just having this constant here. And what logarithmic differentiation tries to do is leverage this law and a few of the other laws that are in my log laws video, which I will link at the top right just about now. So what we're going to do is we're going to take the ln of both sides. So there we go. I've taken the ln of both sides, and let's start breaking this down. So we know the ln, if we have ln of x over y, this can simplify to the ln of x minus the ln of y. So let's use this property right here to simplify this. Now we're going to leverage another ln property that says if we have now xy, not x divided by y, this is going to equal to ln x plus ln y. So now we're going to break this ln apart. So there we go. We have broken these this massive function apart into parts, and now essentially we can start simplifying by using this property right here. There we go. Now that we have dropped all the powers to the front, we have very simple functions, and we can start applying what we have learned about differentiating a ln or a logarithm. So to start differentiating, we are going to need to apply the derivative operator to both sides of the function. Now that we've applied the differentiation operator, we can start figuring out the derivatives of these individual functions. So here on the left side, we have the derivative with respect to x of ln of y. And as we see, this is a composition of two functions. It's a composition of ln and a composition of the function y. Because y is a function, we can think of it as y equals f of x. So it's another function. And to differentiate that, we are going to need to use chain rule. How do we use chain rule? Again, if you still don't know, please check out my chain rule video. I'm going to link it right now. But essentially, we're going to take the derivative of the first function, which is ln, and the way we can do that is by saying 1 over the input variable, which is y. And now we want to take the derivative of the inner function and multiply by that, so times y prime. And on the right side, we can see that this is just a bunch of it's just the sum of a bunch of functions, so we're going to apply the sum rule. There we go. We have used the sum rule to simplify, and now we are going to simplify these derivatives even further. So there we go. And now we have left these ln functions to deal with, and we know how to take their derivative, so I'm going to go ahead and do that now. So there we go. All that's left to do is to simplify. And now that we have simplified everything, I'm not going to merge these into one fraction. Instead, what I'm going to do is just solve for y prime, because that's what we're interested in. So y prime, we're just going to cross multiply this y upwards to the other side. So there we go. And now we have officially found the derivative of this very complicated function in a very smooth manner, and we didn't have to do all of these chain rules and product rules and quotient rules. Instead, we can just use logarithmic differentiation. So yeah, that was a quick little lesson on logarithmic differentiation and the derivatives of logarithmic functions. I hope you enjoyed the video. If it's helped you out at all, please like and comment as to what it helped you out with. Also, if you're new to the channel, please like, comment, and subscribe. And yeah, I will catch you guys in another video.